Modern enterprise networks have become a sprawl of multi-OS devices, physical hardware, and virtualized instances distributed across remote and on-premises environments. Managing these distinct endpoint types historically required a disparate collection of point solutions, each operating within its own silo. This creates a heavy administrative burden, forcing IT teams to constantly pivot between different management consoles to maintain the network. This lack of unified visibility inherently compromises organizational security and data protection, as policies are rarely synchronized across every tool. Achieving a true zero-trust security model, where every access request is strictly verified, remains impossible as long as endpoint management remains fragmented. The Microsoft Intune family addresses this fragmentation by consolidating these management functions into a single architectural framework. While often associated with mobile devices, the Intune architecture governs the entire hardware lifecycle across all form factors. It functions as a cloud-based, unified endpoint management ecosystem, centralizing control over diverse hardware and software profiles. To understand how this works, we will break down the architecture component by component within this empty architectural space to see how it centralizes control. By architecting management around a single control plane, enterprises can secure multi-OS, mobile, and desktop endpoints without relying on physical on-premises infrastructure. Every secure model requires a baseline, and here, that bedrock is Microsoft Entra ID. This cloud-native service manages specific identities of users, devices, and groups, acting as the definitive source of truth for network access. Device enrollment and user access are strictly gated by these Entra ID accounts, ensuring that only authenticated entities can interact with corporate resources. This allows for conditional access policies, using the identity foundation to dynamically allow or block access based on whether a device meets specific security requirements. Sitting directly above this identity layer is the Microsoft Intune Admin Center. The Admin Center is the primary operational layer and the one-stop website for all IT administrative tasks. Admins use this interface to add users, create security policies, and monitor report data across the entire ecosystem from one location. Separating the identity enforcement layer from the administrative interface ensures that security remains consistent even as IT operations are managed from a centralized hub. We now connect the primary cloud-native management engine, the Microsoft Intune service. This service provides cloud-native mobile device management, or MDM, and mobile application management, or AAM. MDM is a security software enabling IT departments to implement policies that secure and manage end-user hardware, while AAM focuses specifically on controlling access to business applications. End users and devices only need an internet connection to be managed by this engine, completely bypassing the need for local infrastructure. This engine also supports non-intrusive AAM to protect corporate data on BYOD assets. BYOD allows employees to use personal mobile devices while keeping personal data separate. For organizations with existing local infrastructure, the architecture includes Configuration Manager. Configuration Manager is an on-premises management engine that utilizes Active Directory and Group Policy Objects, or GPOs. GPOs are a collection of settings that define what a system looks like and how it behaves for a defined group of users. It remains the primary tool for managing data centers, legacy applications, and server operating systems on local networks. The bridge between these two environments is co-management. Co-management allows IT to view and execute actions on-premises devices directly from the web-based Intune Admin Center, linking the local investment to the cloud. This enables a non-disruptive, phased transition of workloads to the cloud, rather than a mandatory replacement of existing systems. Historically, imaging new corporate hardware was a manual bottleneck that required IT to physically handle every device. Windows Autopilot is the cloud-native solution that automates this entire pre-configuration process. Autopilot automates Entra ID joining and Intune enrollment, customizing the out-of-box experience so devices are ready the moment an employee turns them on. The architecture also incorporates virtualized endpoints through Windows 365 Cloud PCs. These are fully functional Windows desktop experiences hosted natively in the cloud and accessible from any device with internet access. Because cloud PCs are enrolled and governed exactly like physical hardware, IT maintains consistent security policies regardless of where the hardware is physically located. Maintaining these endpoints requires constant oversight of patches and updates for both the OS and Microsoft 365 applications. Windows Auto Patch provides a cloud-native alternative to manual update policies by automating the deployment of software updates. By applying updates instantly upon availability, Auto Patch reduces security risks and frees up administrative cycles for other tasks. To monitor the effectiveness of these policies, the architecture includes Endpoint Analytics. This service extracts specific metrics on startup performance, device restart frequencies, and application impact on productivity. Devices managed via Configuration Manager also feed telemetry into this dashboard through the co-management bridge, providing a unified view of fleet health. This continuous telemetry allows IT to move from a reactive help desk model to a proactive strategy, solving performance issues before they impact the user. Large enterprise environments often require specialized capabilities that go beyond standard device management. The Intune suite provides a collection of add-on expansions designed for these advanced administrative tasks. This includes Endpoint Privilege Management, or EPM, allowing standard users to perform specific tasks requiring elevated permissions. It also includes Microsoft Tunnel, a VPN solution securing application data on devices not fully enrolled in Intune. The final overlay in the architecture is Microsoft Copilot in Intune. This cloud-native AI parses internal Intune data to troubleshoot device issues and can automatically create Custo Query Language, or KQL, queries. KQL is a tool used to explore data and discover patterns within massive sets of system locks. As ecosystem complexity grows, integrated AI is used to manage the cognitive load on the IT team by surfacing relevant insights instantly. In this completed model, identity, management engines, automated provisioning, and health telemetry are all interconnected. The resulting control plane allows administrators to enforce a consistent security state across hybrid infrastructures from a single interface. Tools like co-management and Windows Autopilot provide the mechanism for transitioning legacy workloads to modern cloud standards without disrupting operations. The integration of identity verification and continuous telemetry provides the data required to satisfy the strict requirements of a zero-trust framework. The Microsoft Intune family establishes the technical infrastructure required to modernize operations and secure a remote workforce through a unified management framework.